Okay, today we're going to work on lesson 6.3, which is on solving compound inequalities. We've solved one step and multi-step inequalities. Now what we're going to do is combine two of those inequalities with a conjunction and or, and look at how that combination of those words will affect the outcome of the problem. So first thing here is understand what a compound equality is. Like I just said, basically it's taking two inequalities and joining them with the word either and or, the conjunction and or. So if we combine it with the word and, um, that means that the only true outcomes are those that make both inequalities true. Okay, so you're going to have two inequalities, you're going to solve them. The answers to the overall problem are only the answers that make them both true. If we look at the graph, it's the intersection of the two graphs of the individual inequalities. And you're going to see and inequalities or and conjunctions given to you two ways. One way is they can just go ahead and write one inequality, write the word and then give you the second inequality. Okay, and then what we would do is solve each of these separately and then join the graphs with and to get our final answer. The other way they can give you and is actually write it with as one combination of inequalities. With generally the variable is here in the center, and we would read this is 7 is less than x plus 2, which is less than or equal to 11. This is considered an and inequality. All right, so we'll talk about these, and I'll show you how to separate them if they're written like this uh, as we go forward here. The other conjunction that you could have is an or conjunction. All right, and what happens here is again you're going to be given two inequalities, and then they're going to be joined with the word or, and then the outcome here is true if either of the inequalities is true. So any answer that makes either of the inequalities true is considered an answer to the overall problem. All right, this would be done by making the union of the two graphs of the individual answers. And again, when you're given these problems, it's going to look like this. They're going to give you an inequality here. Okay, just a two-step inequality joined with the word or and another two-step inequality. The variables are going to be the same because it's the same m variable that I'm comparing in each one of these inequalities. Okay, so that's a little bit about the and the or. Okay, uh, so what we'll do now is work on translating a sentence into a compound inequality. Okay, so if you look at the directions, it says write the following inequality as an inequality. Use x only once in your inequality answer. So let me show you what they mean by that. So the inequality here is 5 is less than x and 9 is greater than x. So if you look at them separately, you could write it like this: 5 is less than x and 9 is greater than x, right? That's exactly what this says. However, they want you to think of it as a compound inequality with like the one I showed you earlier, which is there'd only be one x in it. All right. So here's the way we look at it. So and tells us that the values of x have the only values of x that are true are the ones that make them both true. So if you think of a number line, what are the numbers on a number line where the x's are greater than 5 and also less than 9? Well, if you looked at it, it looks something like this, right? The part of the graph I have shaded in here are numbers that are greater than 5 and at the same time less than 9. All right. Now the open circles here means 5 is not an answer. That's because it was just greater than, it wasn't equal to. And 9 is not an answer because it's just less than but not equal to. Okay. It's all the numbers in between here. All right. So that's what a graph of an and would look like. Now the way we would write it with just one variable would be like this. Okay. So if I was to read this, I'd read it kind of inside out, like x is greater than 5 and x is less than 9. Kind of speak of it as the x variable in both cases. So right here, it shows you're getting all the numbers between 5 and 9, which are right here on the graph. But, in your directions, it said use x only once. So that's the idea. They want it written like this. Okay. This is the same thing. Okay. But they want it written like this. Okay. Another one here. X is greater than or equal to -2 and less than or equal to 4. So if I just write it directly, it looks like this: x is greater than or equal to -2 and x is less than 4. Okay. So again, and tells us that both values have to be true. That the answers for X have to make both of these two true. So if you look at it graphically, okay, we're looking for numbers that are greater than or equal to -2, but also less than or equal to 4. So that would look like this graphically. Okay, all these numbers I have shaded in here are numbers that are bigger than -2 and they're less than 4. So all these numbers fit both criteria up here. Okay, and again, the solid is because of the equal to in both cases. Okay, now if I was to write that as one inequality, or excuse me, with only one X in the answer, I'd write it like this. X is greater than or equal to -2 and X is less than or equal to 4. All right, so that's what they're looking to get you to do here. All right, it might count it wrong if you write it like this because you're using X twice. They only want you to use X once. All right. All right, so now they just want us to graph these. Okay, now I'm going to do ands and ors. Okay, so graph this compound inequality on a number line. All right, so we're going to graph X is greater than or equal to 3 and X is less than 5. Okay, so what I will do is that sometimes they're called thinking graphs, or I've heard somebody at one time call them thinking graphs, where they actually going to graph both of the inequalities separately and then decide how the answer will be by looking at the conjunction. All right, so this first graph are X values that are greater than or equal to 3, closed circle on 3, and we're going to shade our number line to the right. The second graph is X is less than 5, open circle on 5, shade to the left. All right, now the conjunction is and, which means we're looking for numbers that make both of these true. Okay, so it's got to be greater than 3 and less than or equal to 5. So the way I think of it is if you were to push these two number lines together so that they overlapped, the numbers that are commonly shaded in both of these are our answers. Okay, so the word and tells us the final graph has to include points from both equations that make both equations true, or the intersection. So if I was to push these two together, the overlapping parts would look like this. Okay, 3 is shaded in this one and it's part of this answer group. You can see 4 is in the answer group. 5 is in this answer group, but not this one. So it's an open circle. And those are the only common numbers between the two graphs. So you push them together and whatever overlaps is your answer. So you can see clearly here that all the answers I have shaded are numbers that are greater than or equal to 3 and also less than 5. Okay. So that's and. Now let's look at how or works. Okay, again, what I'll do is graph each of these separately on number lines. So here is X is less than -4. All right, and here is X is greater than or equal to 2. Now, or says as long as our answers make one of these two true, then it's part of the answer group. Okay, so or says the final graph must include points that make at least one of them true, which is a union. So when I think of or, what I think of is let's push the two graphs together, and then everything that's in either of the two graphs gets included in the final. So if I were to push these two together, it would look like this. Okay, so all of these numbers over here, greater than or equal to 2, make this inequality true. All of the answers over here, which are less than or equal to 4, make this one true. So all of them are answers in the outcome because my conjunction was or. It said all I got to do is make one or the other true, so all of them count. Okay, so that's how or works. Okay, doing another one here. So X is less than or equal to -7. There's that graph. X is greater than -4. That's that graph. My conjunction is or. So that means both sets of answers will work in my final answer group. So it looks like this. Push it together, keep all your answers possible are final answers. And X is greater than or equal to 1 and X is less than or equal to 5. So there's my greater than or equal to 1. There's my less than or equal to 5. So and says the only answers in the final have to make both true. So when you push them together, only the overlap numbers get counted down here in your final version. So this graph represents all numbers that are greater than or equal to 1 and at the same time less than or equal to 5. So there's my answer. That would be my final answer, the one I would show in my solution there. Okay. Oops. Okay, now they give us a graph and say, you give us the inequality, the compound inequality that represents the graph. All right, use X for your variable. So, I mean, really, you just got to kind of read it to yourself. This answer group represents numbers that are greater than or equal to -3 and numbers that are less than 7. The only way I'm going to get this group is to use and. Now, I can write it like this. Remember, as a compound, and can be written like this. So if you read it inside out, X is greater than or equal to -3 and X is less than 7. So that's your compound inequality here. I don't know what Alex will do if you write it, as two separate with joined with and. It may be fine. I don't know. Okay, down here, the only way we're going to be able to say this answer is with an or, because they're headed in opposite directions. So there's no common answers between these two graphs. So we're going to have to use or. We're going to say X is less than 2, less than or equal to 2, or X can be greater than or equal to 7. It can be in either one of these answer groups by the way they have it written. Okay. Here, it's going to be an and, right? So it's going to be X is greater than or equal to. So again, I read it inside out. X is greater than or equal to 3 and X is less than 6. Compound inequality. You make sure you're looking open circle, closed circle as to which symbol you're going to use. And then finally, this will be an or, right? So we're going to say X is less than -1 or X is greater than or equal to 5. All right. So that's how we do those graphs, kind of making your own graphs and then looking at a graph and deciding how it's represented. All right, that takes us to actually doing some of these compound inequalities, and this is what it's going to look like. They're going to give you a compound, or excuse me, they're going to give you a multi-step inequality. They're going to join it with the word or and then they're going to give you a second one. Okay, so this says solve the compound inequality, then graph the solution. All right, so what we're going to do is just solve them individually. So solve the first one here. Well, we would add 2 to both sides. And then we want to make the coefficient of the x become a 1. So we're going to divide each side by 3. And the first one is x is less than or equal to -3. No problem. Second one, solve it. Add 2 to both sides. 2x is greater than or equal to 12. Divide each side by 2. X is greater than or equal to 6. And then you got to remember what you're joined with. You're joined with the word or. It makes a difference whether it's and or here, right? So when I graph this, I want to get the answers to my problem are any x that's less than or equal to -3 or any x value that's greater than or equal to 6. So it's going to look like this. Okay. Closed circle, less than or equal to -3 is that way. Closed circle, greater than or equal to 6 is that way. That's how your answer would look. Okay. Another one. This one has an and. Okay. So no difference. They give us 2 multi-step inequalities. They join it with and. So you start by solving each one separately. So subtract a 4, right? Divide by a 2. X is less than 6. Take my second one, subtract 6. Okay. Divide each side by 2. X is greater than 3. Join it with the word and then graph it using the word and. So I want all values that are less than 6 and at the same time greater than 3. So less than 6 and greater than 3. Again, it's open circles because there's no equal to symbol here. And these are the numbers that fit both criteria. Answers have to fit both criteria. All right. So again, it becomes pretty basic here. So solve each inequality, subtract a 2. Careful here, -4 minus 2 is -4 plus -2, that's -6. Divide by 3. X is greater than -2. Okay, over here, subtract a 6. -14 minus 6 is -20. Divide by a 4. X is greater than or equal to 5. And again, the word joining it is or. That's the key. So now my final graphed answers are answers that make either one true. So I want to graph answers that are greater than -2 or answers that are greater than or equal to -5. Okay. Oops, that should be a less than. Sorry, guys, I boogered that up. That should be there's no reason to change this inequality. I didn't divide by a negative. That should be less than, and the graph's correct. This answer over here isn't. Okay, so x is less than or equal to -5 is this inequality's answer, and greater than -2 is this one. Okay. Okay. Last one. Okay. Now the last one here, they give it to us in this format. Okay. Now there's two ways to go about this. The first way is a little bit longer, but it's good for you to see because you need to understand it. All right. So what you can do in this case is you can actually divide this into two individual inequalities. Okay. The middle piece here, it becomes part of two inequalities. So the first one would be -6 is less than 3x minus 6. And then the second one would be 3x minus 6 is less than or equal to 9. Okay. So the center part here becomes part of each inequality on each side. Okay. So I got it joined with the word and because this is an and style here. Now I just solve them each separately. So I switch sides because I always like to have the variable on the left. Remember when I switch sides of the inequality, I switch the inequality and now I solve it. So I'm going to add 6. So 3x is greater than 0. If I divide each side by 3, I'm going to get x is greater than 0. Solve this one. Add 6. Whoops. Add 6 to both sides. 3x is less than or equal to 15. Divide each side by 3. X is less than or equal to 5. And we're joining it with the word and. So then I would graph this. Okay. Now, the second way to do this problem, and it works in this situation, would be to leave it like this and then kind of treat it like you're just solving a regular inequality, but there's three parts to it. There's, instead of just being a left side and a right side to your inequality, there's a left side, a middle, and a right side. So whatever you do to one section of it, you got to do to all sections. So what I'm showing you here is this. If I was solving, still I'm working right here. This is what I'm working to do is to get the x here by itself, make it a 1x. So the first thing I want to do is add 6 to make this a 0. So if I add 6 to the center, I got to add 6 to the left, add 6 to the right. Okay, that would give me 0, less than 3x, less than or equal to 15. Now I want to make that 3 right here become a 1. So I'm going to divide all sections by 3. That gives me 0 is less than x. Excuse me, yeah, 0 is less than x, which is less than or equal to 5. And if I graph it, this is the first, these two graphs are the same, right? The answer to these two are the same answer. So it's the same graph. But anyways, if I look over here, x is greater than 0. So those numbers are greater than 0. And x has to be less than or equal to 5. So there's your group of answers. Over here, read it from the inside out. X is greater than 0 this way. X is less than or equal to 5 this way. Same graph. Okay? So you can do it either way. I thought you'd like to see that. All right, so that's what we're working at right now. Okay, we're going to work on solving compound inequalities, do some of the basic work of the graphing and understanding the and or first, and then get into some of the inequalities. Guys, make sure you're writing these down. Make sure you're writing them out and solving them so that you can see the work and understand how the work fits to everything we're doing. All right, homework's going to follow those examples closely on Alex, and I will let you have at it.